Welcome students. Today we are going to continue the queue concept. Today I wish to discuss a double-ended queue. Previous session we had a discussion in linear queue, and there may be some drawbacks in linear queue. To get rid of that, we have used a circular queue. Here I explain another kind of queue called Deque. Deque is also called as Deque. Stands for double-ended queue. It allows the elements to be added or removed on either the ends. In linear queue or circular queue, we do insertion at the rear end and deletion at the front end. But in double-ended queue, in either end, we can insert the element or delete the element. There are two kinds of double-ended queue which will be discussed later. Here we have front end and rear end. We do insertion and deletion on the rear end and insertion deletion on the front end. This is the simple illustration of double-ended queue. I told already there are two kinds of double-ended queue. One is input restricted, another one is output restricted. In input restricted queue, elements can be inserted only one end, that is rear end. But elements can be removed from both the end, that is called input restricted. In output restricted, elements can be removed only one end, that is front end, and elements can be inserted both the end. Okay, so you got to know about the difference between input restricted and output restricted. In input restricted queue, we do restrict insertion operation, that is in rear end only we can insert. In output restricted, we do restriction in deletion operation, that is we can delete the element in the front end only. Okay. So here I explained four operations pertaining to double-ended queue. Insert element at rear, insert element at front, delete element at front, and delete element at rear. If we use input restricted queue means we can use insert element at rear and delete element at front and delete element at rear. If we use output restricted queue means we can use insert element at rear and insert element at front and delete element at front. So I am in a position to implement four operations for implementing the double-ended queue operations. First I explain inserting the element at rear, which is equivalent to linear queue only. So here I have renamed the operations NQ underscore rear, which accepts one argument, that is element to be inserted, which returns nothing. If rear end equal to maximum size minus 1, you can say that queue is overflow. Immediately return that. If you are trying to insert the element for the first time, means just check front end minus 1 and rear end minus 1 and set front and rear end value to 0. Otherwise, just increment the rear end itself by 1. Finally, you can set the newly inserted value to the queue by using this expression q of rear equal to x. This is the insertion operation at rear end, which is used in both the input restricted queue as well as the output restricted queue. Next, Deque front, which is equivalent to linear queue operations only, because in linear queue we are deleting the element front position only, no. So this is equivalent to linear queue Deque operation. First check whether a queue is empty. If it is empty means just say underflow, and else just check whether you are having only one element in the queue. If it is, just set front end and rear end equal to minus 1, just like resetting the front end rear end pointer. Otherwise, just increment the front end by 1. This is the Deque front operation, which is equivalent to linear queue Deque operation only. Next, we have specialized insertion operation called Deque and rear. Usually in linear queue and circular queue, we do insertion at the rear end only. But here we are dequeuing, that is deleting at rear end position, which is used in input restricted queue. When you try to delete the element the rear means the rear end should not be -1. If rear end is negative means it means that you don't have no element in a queue. If it is so, just say just queue underflow. Otherwise, just decrement the rear counter by 1 because we are deleting the element rear position. So we are in a position to decrementing the rear pointer by 1. It's very simple, no? Just decrementing it. If you are deleting at front end means just increment the counter. Okay. Then other special kind of operation, NQ front. Usually we do insertion at the rear end, but in double-ended queue we may insert element at the front end. For example, you are having set of elements in a queue and you are trying to insert the element front person. For example, if front end value is equal to 0 means first person we have element. If it is so, you can't insert it to the front end. If front end value is greater than 0 means we can insert it because we have some free spaces in the front end person, no? If you have free spaces in the front end means the front end value may be greater than 0. At that time we can insert the front. But if you have front end value greater than, I mean, that is less than or equal to 0 means you don't have any data. That is front end value. You don't have any data. There is you don't have any free spaces in the front end person, so you cannot insert. That is why I have checked front end less than or equal to 0. Else, just decrement the counter by 1, front counter by 1, and for giving the free spaces to insert the element at the front position. You can set the value that is to be inserted in the memory block by using the key of front equal to x. So this is the operation begin NQ front. Okay. So I just show the demo for queue operation. We have operation is already implemented. We have implementation of linear queue already. So I have already implemented linear queue, just extending it by using NQ. Yeah. Very simple, no? Then DQ, it is already available. Now I am in a position to implement NQ front. Okay. Have a function NQ front. Just to check if front end equal to 0. Check. We can't. Yes, front end 0 means we have no space in the front end person. Return it. Else increment to front end equal to front end -1. Set your front equal to x. That's all. Next you need to implement DQ rear. Have the function Deque underscore rear, which has no argument. If rear end equal to minus 1, it means that we have no element in the queue and we can delete. Let's say print delete add rear. Immediately done. Otherwise decrement the rear end. This way I can implement double-ended queue. See here, same operations only. NQ file. Actually, we are dequeuing front. So this is a special feature in double-ended queue. NQing front, then dequeuing rear, then NQing rear is equivalent to linear queue, and dequeuing front is equivalent to linear queue. Finally, I am displaying the data in double-ended queue. Here, we need to redefine the function in main function. NQ rear, Q means DQ front, 3 means NQ front, 4 means DQ rear, 5 means display, 6 means exit. Okay. Here I need to set the NQ rear, DQ front. Case 3, we have to use NQ, but we are inserting the element at the front, NQ front. Next, case 4, we are just DQing at the rear. And then queue break. In case 5, displaying it. In case 6, you are exiting it. Okay, we have redefined the main function for the purpose of calling 4 functions, which is divided in the double-ended queue. Just name it DQ or Deque. See here, just I am NQing rear portion. 10 and displaying the data here and inserting 20 and displaying data. We are talking now. Here in front end we don't have a free space, and I am trying to insert the element at the front by calling third option. I'm just trying to insert that. So it is saying we can insert because we don't have no space in front end, no, so we can't insert. Now I am going to DQ front end. When I try to DQ front, I call 2. Now display. I have 20 now. I have only one element. Okay. In this way I can implement double-ended queue. If I try to insert element at different position, means it is possible now. By calling setting 40. Now it is inserted. Just see the data. I have inserted an element in front position. This is the use of double-ended queue. Usually we do insert the element at the rear end, but here we can insert at the front end. So if, for example, if we have one process which is stored in the queue, already it is stored in the queue, and we have another process which has higher priority, means we can insert the front end person to promote to process first. Okay, this way we can implement double ended queue. Just exiting. Now I am discussing about application of queue. There are several applications which is pertaining to queue. The design of printer spooler for managing the printing job in a printer. We use queue concept, that is linear queue concept. Then in computer networking, there is one concept called packet forwarding in routers. So if we are trying to send some data to the recipient or receiver, means we need to follow the queue concept. First send the data, maybe received to the received by the recipient first, based on the order of delivery. That is packet forwarding routers. The application of one of the application of queue. Then CPU scheduling. So operating system having functionality, that is scheduling. It maintains a queue of process that are ready to execute or that are waiting for an event to occur, which follows the queue concept. For example, some of the queue concept called first in, first out. First loaded data or application in the operating system may be executed first. Okay, so CPU scheduling is happening with the help of queue only. There are other schedule methods available, like round robin scheduling, then priority scheduling. That is also available in the operating system concept functionalities, which also makes use of queue. There is other variant of queue. Then message queue in Windows. Actually, computer system must often provide holding area for message between two processes, two programs, or even two systems. So the communication between the two programs and two processes and even two systems, that is happening based on the queue. For example, you are trying to open Windows applications, or the minimizing the applications, then maximizing the applications, and closing the applications. That is happening now. That is based on queue only. For example, you have you are trying to close. Consider your system is slow. You are trying to minimize the application, and immediately you have clicked the maximizing application, means first the operation which is done first or executed first. Okay, based on the queue only it is working. Then IO buffering, when data is transferred asynchronously, it is based on the sequential order. Data not, I mean the data are not necessarily received at the same rate as sent. For example, if you wish to transfer the data synchronously between the two processes, means we can use buffering concept. The buffering concept involves queue. So we realize many applications pertaining to queue in operating system, both hardware as well as software systems. Okay. Tomorrow we will discuss context problems which is relating to queue concept. Okay. Thank you.